For subsea operations, there needs to be a specialized conduit that ensures that drilling fluid moves all the way from surface down past the seabed into the well without contaminating the environment. There also needs to be equipment that ensures that the rig remains stable while we drill the wells, compensating for the vessel movement. These are the sort of equipments we'll be talking through today. So, good day, everybody. Welcome once again to um, subsea drilling operations. In today's presentation, we'll be speaking through some specific equipment that also help for well construction in subsea environments. As we speak and talk through it, please take out your time to click on the subscribe button while we proceed. So the outline we'll be looking at today, we'll be looking at a couple of equipments we'll be looking at today. We'll be looking at the Heave Compensator. We'll be looking at the riser fill-up valve and the riser. We'll be looking at the telescopic joint. We'll be looking at the riser tension system, the flex joint, and we'll be looking at watch circles. That is circles that tell us, that guide us when to remain drilling or if to get off the location when required. If you look here, you see that most of this equipment that we'll be looking at today pretty much are connected to the riser system, which is a conduit from surface all the way to the seabed. And if you are asking questions, wondering what this is, yes, this is a Christmas tree. This is a man standing next to a Christmas tree. So I'm sure that kind of answers your question and also tells you how large some of these equipment can be. So moving right into the presentation, just to show us the sort of equipment to be speaking about. These two diagrams kind of represent the same thing, but it's just for us to be able to outline some of the equipment that I'll be talking through. So from the top here, we have your riser tensioners and you have your telescopic joint. It's pretty much the last joint connected to the riser tensioners. Then you have your riser going all the way from the rig, all the way connected to the BOP system, to the wellhead system, and down here you'll be drilling your well. So these are the equipments we'll be speaking about today. We'll be speaking about the riser tensioners, we'll be speaking about the telescopic joint, we'll be speaking about the riser itself, we'll be speaking about the flex joint. And those are the couple of two equipments. But we'll also be speaking about the heave compensator somewhere up here that ensures that that the equipment that we will be running the well remains on bottom and completely annuls the heave of the vessel while doing drilling operations. Yes, so jumping right into it, this is the first equipment that I'll be talking through, the heave compensator. It's mostly used by the semi-submersible and drill ship, that's floaters, for obvious reasons, because while we are drilling, the vessel undergoes movement due to waves. So it sees the roll, it sees the heave, the surge, the sway, the pitch, and this particular equipment helps to keep the rig properly positioned and undisturbed by the heave. So it's used to reduce the wave-induced vertical movement of the drill string when drilling. So when the heave affects us during drilling operations, the rig tends to see some vertical movement. So what this piece of equipment does, is ensures that even when the rig moves, that our drilling assembly remains fixed on bottom, and that up and downward movement, that's that heave movement, the vertical movement up and down, doesn't affect the drill bit or whatever tool we are running down on bottom. So how does it do this? It has a, the way the jack system, when we want to change our tires, supports, lifts up the car. It sort of does that. The piston system in the hydraulic unit sort of does that to sort of puts on that force on on the block system, and when it does that, it suspends it. So regardless of whatever movement you are having with the rig system, it keeps the assembly on bottom. This was first built by ABB Vector Gray in about 1970 and was installed on this vessel, the Wadeco 4. There are two types generally: the single system and the double system. And like I said, it ensures to keep your bit on bottom. And when your bit is on bottom, you achieve higher penetration rates because it prevents your bit from bouncing off up and down. It keeps the bit on bottom and enables you to drill off as required. Then when that happens, your bit leaves, because when when you are constantly having that bounce off the bottom up and down, there's a tendency for your for your drill bit cutters to break off. There's a tendency for it to break out the cones if you're using a roller cone bit. And finally, there's a proper landing of the BOP and other tools. So even with the rig heaving up and down, if you have the compensator active, what it does is that regardless of the movement, you're going down, and your depth as you're going down is fixed, and the heave is completely annulled. So that's pretty much this system helps us offshore. So I said on the other slide, we have a single and a double system. And just to put that up, these are the components. But I'll be throwing the spotlight on the hydraulic system, which is somewhere. So these are the piston rods. So what it does in these cylinders is that it provides the required pressure. I mean, we all cannot remember that basic equation: pressure, force over area. So it provides that pressure in this system that helps to keep it helps to keep the motion stable up there. That's on the crown. And when that happens, the bit remains on bottom. So regardless of the motion that the rig is going to be having, the system remains on bottom. The next piece of equipment we'll be talking about is the marine riser. Of course, as we said, it's the link between the well and the rig. It serves as the return part for the mud during circulation. So it goes all the way from the top of the rig, from the top of the rig, all the way into the well. So every fluid we are going to be flowing as per mud systems is going to be flowing through in here and back all the way to surface. So this is our water. This is the sea here. We don't have any sort of contamination with the sea. So it's the conduit that goes all the way from the top all the way into the well and back to surface. It's usually manufactured in lengths of 50, 75, and 90 feet, and it supports the BOP stack during retrieval or rundown. So what we're trying to say is that it is connected to the BOP. It's, if you notice here, the first joint will be connected to the blowout preventers, and you will run it all the way from surface down. And also, when we want to recover the BOP system, we also use the risers, pick up from the last joint, and pull up to surface as we disconnect the risers and lay them out, and we just go ahead to recover. Hold it up with the spider, the riser spider running tool, and we go ahead to recover and lay out the risers as we recover. It should accommodate the extra tensioning forces and lateral forces experienced by the deep water mode. So what it means is, while this is installed, every force that acts on the riser, these riser joints should be able to accommodate it. And there's buoyancy material to compensate for the extra weight of the long riser. So what this is saying, or what this is saying, is that all the risers that we're going to be running here, if you notice, there are some in red called the buoyancy joints. Now, what those buoyancy joints are, it makes the riser system not so heavy. All these joints are slick joints. If all the risers that we're going to be running are slick and don't have this buoyancy system, what this buoyancy system kind of does is it reduces the downward forces. You are running risers on risers on risers. That is on bottom will be seeing a lot of weight compared to that's on the top. So when you have the ones at the top, when you kind of put buoyancy materials on the ones on closer to surface, it reduces the mg, that's the weight that is acting on the ones below, and that way prevents your riser system from buckling during operations. um and because of this riser system, there is, the riser joints that you need, there needs to be a lot of deck load for you to be able to have them on board before you run, and even when you're going to recover them, as you recover, break them out to lay them on surface. So you will definitely need some deck space. So these are what riser joints look like. What you see here is the risers on surface with the buoyancy joints. So what you see, they look like synthetic material, but what they do is that they help to keep the riser system light, because you see the way they are. Because of that extra OD, there will be some buoyant forces acting on them, and it kind of makes it lighter, preventing the weight on the joints that were run initially, the first joints that were run to it reduces the weight on the initial systems or initial riser joints that were run. The next tool we'll be discussing is the riser fill-up valve. So it's actually one of the components of the riser system, And what this tool does, just quick summary, is that when drilling, now there in environments where there are multiple fractures, there's a propensity for losses. Now the losses could be so huge that the fluid system in the riser drops significantly. And when that happens, and there's a possibility that you might lose all the fluid in the riser. And when that happens, what I mean, the riser is a tube. What happens? You don't have fluid in the system, so you don't have any force acting inside the riser. There will be collapse. And so what I'm saying is, when you lose all the fluid, the riser collapses. Now, what happens? Bec- like we said, in deep water operations or in offshore operations, the system is designed in such a way that we always have redundancy, something to get us out of jail. So this riser fill up valve is one of those tools. So what happens is, it is designed in such a way that once you start losing so much fluid and it gets to a particular level, instead of this riser to collapse, a slip opens, a valve opens, and we have seawater come into the system. Now, it is preferred that seawater comes into the system and pretty much fills it up, instead of us having nothing at all. So that's what that valve does. So just looking at a couple of highlights, is mounted on the riser to prevent collapse of the riser and level, and prevents that level when the fluid drops. It could be the loss of fluid could be as a result of perhaps when we drive off, or an intentional drive off, perhaps maybe when we are drilling and maybe when we are drilling and perhaps we need to get off the location quickly because of an incident, and or there's lost circulation, or there's an accidental line disconnection due to the very bad due to the bad weather or the bad environment, and you have a lot of vessel movements. uh, when that riser pressure drops, the hydrostatic pressure pushes up the sleeve on the valve. So this is what the riser fill up valve looks like. So when that pressure drop happens, this the hydrostatic pressure, I mean, is noticed in the system, and it pushes up that sleeve. And when it pushes up the sleeve, we start getting fluid into the system, and it fills the riser back up and prevents that riser system from collapsing. So the next tool that we'll be looking at is the telescopic joint. This is what it looks like. It is the top joint of the riser system. So it's up here, and it's used to compensate for the up and down movement of the vessel. So it's like a piston just goes up and down. The inner barrel, somewhere up here, okay, is going to be attached to the diverter, while the outer barrel, which is what you see here in purple, is going to be attached to the tensioner system. Now, the tensioner system is somewhere on the rig, on I mean, pretty much on the vessel. So what that does is that it helps to keep the riser in tension, as the name implies. So the tensioner keeps the riser in tension, while the inner barrel strokes in and out. So it's a complete system. So while the telescopic joint goes up and down, responding to the heave of the vessel, the tensioning system keeps the riser tensioned and prevents it from collapsing. So the outer barrel supports the terminal fittings for the choke and kill lines. So somewhere out here we have your choke and kill lines connected, and the outer barrel provides the terminal fittings for those lines. I mean, we'll be discussing the choke and kill lines when we're discussing other equipment like the blowout preventer and the rest of them. Those are the equipments that ensure that we maintain well controlled while drilling. And it also provides attachment for the riser tensioning system, which is somewhere up here. So this outer barrel here is attached to tensioning system, like I initially explained, and ensures that the tension that the outer barrel connected to the rest of the risers is kept in tension, and they are made up in 55 to 75 foot strokes. So this is what the telescopic joint looks like. So you have your the ring here, and you have your inner barrel. So this outer barrel here is connected to the tensioner system somewhere up there. You can't talk about the telescopic joint without talking about the riser tensioner, which is going to be the next piece of equipment that we're going to be looking at. So it provides that axial tension that it's pretty much pre-selected because we already know what the weight is going to be, all going all the way to bottom. So you know what tension you want to put on the riser to keep it, to keep it, give it the required tension. Then it supports the marine riser, keeps it in tension, and also provides compensation due to the rig movement. I already spoke about it in the other slide, but I'll quickly highlight it here. So as we said, the last joint here has the telescopic joint here, and the outer barrel is connected to the tensioner system. So like I said, you can't speak about the telescopic joint without speaking about the tensioner system. So the outer barrel is connected to the tensioner system, then the telescopic joint is in here and responds to the heave movement while we're drilling. So that's what it looks like. It's a huge piece of equipment. I just put it here so that we can see the size in relative to the size of a human being. So the flex joint is one of the tools that is almost at the terminal end. That's it somewhere here. So it's the normal operating angle is about 1.5 to 1 degree, and immediately it starts getting to 2 degrees, we think of to stop drilling. So what will cause a the flex joint to get up to 2 degrees? Of course, when the rig moves out of position. If you notice, this rig would have been somewhere initially here, and perhaps due to the weather, it has pretty much dodged the rig well away from well center, and we are getting up to we are moving away from a degree to perhaps 2 degrees. So that flex joint is what ensures that we have that flexibility. Else, this riser system would have just been rigid all the way from top to bottom. That flex joint gives the opportunity for when the weather acts on the system. At least the flex joint gives us some redundancy, or enables us to be able to drift from side to side, but however not above 2 degrees. So you cannot speak about the flex joint without speaking about what's circled in the diagram to the right here. It shows us going from inward to out. Moving from in all the way out are circles where some particular actions need to be taken. So in green, clearly we are good, we are drilling, we don't have any issues. But once you start moving out to yellow, I pretty much call it the warning. And at this point, you should think of stopping drilling operations and start getting ready to disconnect. Ladies and gentlemen, by the time you are red, you have pushed the EDS button and you have disconnected. Now, the most important point is, by the time you are red, I see red as the most important point, because the idea is, by the time you are red and push that button, would have given you enough time so that by the time you're at the point of disconnect, you've disconnected from the wellhead and you've moved away. At that point, the lower marine riser package has fully disconnected and has moved away. So the red point is very, very important, because if for any reason at this point that decision has not been made, or the EDS has not been pushed, we might not fully disconnect and there might be a mishap and possibly damage to the wellhead system, because the LMRP won't have disengaged completely. So this is just a vertical section view of what we're speaking about. White, by the time we're here, prepared to stop drilling. Around this green point, we're okay. Prepared to stop drilling. And by the time you're here, you would have pushed the EDS button, so that before you get to red, you're in a good place. So those are the piece of equipment we'll be looking at for this video. Thank you once again for following us to the end of this video. We'll see you in the next video discussing other subsea equipment. Thanks again once again for getting the end of get to the end of the video. Please do not forget to like, share, comment, and most especially subscribe and push on the notification button so that you get updates when we post a new video. Thank you once again, and bye for now.